Welcome everyone to a lecture on the topic of graphing quadratic relations. We have a quadratic relation in standard form. The equation is y equals x squared minus 6x plus 5. And we want to draw the graph of this quadratic relation. The exponent of x is 2, as you see, and it's called the degree of the quadratic relation. Always the highest exponent of x in a relation or in an algebraic expression is the degree of that relation. If the exponent was 1, we say that the degree of the relation is 1. If it's 2, like in this case, we have a quadratic relation, we say the degree is 2, and if it's 3 or 4, we say the degree is 3 or 4, and so on and so forth. So in order to draw the graph of this quadratic relation, we have a table of values here. We are selecting some x values, some input numbers for the relation, and these numbers can be selected arbitrarily. You can choose anything you want. I have chosen -1, 0, 1, 2, 3, all the way to 7. And then the value of y, of course, is calculated according to the given quadratic relation. So if you wonder where this 12 is coming from, well, we say x is -1. So when you plug in -1 for x and you square that, you end up with 1, because -1 all squared is 1. Minus 6 times -1 is positive 6. So 1 plus 6 is 7 so far. 7 plus 5 is 12. So that's how the 12 is calculated. If x is -1, the value of y is 12. We can calculate this by substitution. Similarly, if you plug in 0 for x, so 0 minus 0 plus 5 would be 5. That's very easy to calculate because 0 squared is 0 and 6 times 0 is 0. And if x is 1, we plug in 1. Again, 1 squared is 1 minus 6 times 1. That would be -5 plus 5 would be 0. So that's the value of y. And similarly, for all different values of x, we can calculate the values of y. You may notice that we had 5 for the value of y when x was 0. So if you plot this point 0, 5, that is actually called the y-intercept of the graph. So when we draw any kind of graph and that graph intersects the y-axis at some point, in this case 0, 5, we say that the y-intercept of the graph is 5. And that is when x is 0 all the time. And then on the other hand, we had another case here where y was 0 and x was 1. This point I want to mention. So x is 1, y is 0, and this point is on the x-axis, and we call this x-intercept. In fact, there's another point where the y-coordinate is 0, and that is 5. So 1 and 5 are called the x-intercepts of the graph, or we also call them zeros of the quadratic relation. So zeros of the relation or the x-intercepts of the graph is the same thing. And in the table of values, whenever you see that y is 0, like here, y is 0, and x is like some number, like 1 and 5, those numbers are the x-intercepts of the quadratic relation. Now that we completed the table of values, we can plot these points one by one. -1 and 12 is right there. 0, 5, we already had it. 1 and 0, 2 and -3 is going to be right here. And then we have the other points, 3, -4. And then we have 4, -3. And then we have 6, 5. And finally, 7 and 12. So these are all the points from our table of values that we plot here. You may notice that there is one point here whose y-coordinate is -4, and that's the lowest point among all these points. Later on, I'm going to tell that that point has a special name. We're going to call it the vertex of the graph. But now that we plotted all of these points, let's draw a smooth curve passing through the points and come up with the actual graph. And you can easily do this on a piece of graph paper certainly using a pencil. So I'm going to draw a smooth curve passing through the points. I will never use a ruler. I will not connect the points with straight lines using a ruler, but I'm going to draw a smooth curve passing through the points, and we end up with a very nice U-shaped symmetrical graph, which is called a parabola. So the name of the graph of a quadratic relation is a parabola. Here is the point I was talking about earlier. 3, -4 is the lowest point on the parabola, which is called the vertex of the parabola. It is the lowest point on the curve, also known as the minimum point. And as I said, the graph is a symmetrical U-shaped kind of graph. And if you draw a vertical line, like this dashed line, it's called axis of symmetry, and it's a very proper name chosen for this vertical line because it actually cuts the parabola in half, and the two branches of the parabola are symmetrical with respect to this vertical line. This line definitely passes through the vertex, so its equation would be x equals 3. That's the vertical line. And the parabola itself has the equation y equals x squared minus 6x plus 5. You have to always remember to label both the graph and the axis of symmetry after you finish graphing. Also label the vertex. These are all good graphing habits. And in this case, we see that the parabola is opening upwards, and we have a lowest point on the parabola. This is the vertex, and the vertex is a minimum point in this case. Now, sometimes that's not the case. Let's consider another quadratic relation like this one, y equals -x squared minus 8x minus 5. The difference between these two is that the coefficient of x squared term, or the so-called a value, is positive in this case, and we notice that the parabola was opening upwards, but in this case, the coefficient of x squared term, or the so-called a value, is negative. It's -1. So when you graph this, you end up with a parabola which is opening downwards. As a result, the vertex is the highest point on the parabola this time, not the lowest point as we had before. So before we said that lowest point on the parabola, the vertex, is a minimum point when the parabola opens upwards. But here, we're going to say that the vertex is a maximum point because the parabola is opening downwards. So always you end up with either the case where the parabola opens upward or the case where it's opening downwards. And there is no third case scenario because obviously the coefficient of x squared is either positive or it's negative. End of the day. Okay. We mentioned about the y-intercept, the point where the graph intersects the y-axis. We mentioned about the x-intercepts, also known as the zeros of the relation. Those are the points where the graph intersects the x-axis. We talked about the vertex. We said that is the lowest point or sometimes the highest point. And another thing I want to mention here is that if you look at the x-intercepts, one is 1, one is 5, right? And it's needless to say that the vertex is exactly in the middle between these two x-intercepts. If you think about it, it's exactly midway. And whenever you want to find the middle value between two values, you always find the average of those two. So if you find the average of 1 and 5 by adding them up and dividing by 2, 1 plus 5 is 6, divided by 2, that's 3. That would be the x-coordinate of the vertex. So given the two x-intercepts, you can always find the average by adding them up divided by 2. That would give you the x-coordinate of the vertex. So something to remember. And this is coming from the nature of the parabola, which is a totally symmetrical graph, obviously. That was the x-coordinate of the vertex, which is also used to write the equation of the axis of symmetry. X equals 3 is the equation of this vertical dashed line that is passing through the vertex. But about the y-coordinate of the vertex, I should say that y-coordinate is called the minimum value of the quadratic relation. It's also called optimal value. But specifically in this case, because the problem opens upwards, it's called the minimum value. So if somebody says, what is the minimum value of this quadratic relation? You're going to say it's -4. Similarly, the maximum value of that other parabola is 11. You always look at the y-coordinate of the vertex, whatever number that is. That is either the maximum value or the minimum value. Maximum value whenever the parabola opens downwards and the vertex is a maximum point, and it's a minimum value whenever the parabola opens upwards and the vertex is a minimum point. Maximum minimum values are also known as optimal values, as I said. Optimal value is like much more general terminology, but specific words used are max value and mean value. Okay, so I hope you learned how to draw the graphs of quadratic relations by plotting the points and drawing a smooth curve passing through the points. Just always remember to label the graphs and their axis of symmetry as well as the vertex. Okay, thank you for your attention.